for this. Great. No, we're still not able to see your screen, Anush.
Yeah. Now,
Yeah. Yes, we can.
are you seeing the screen which has my workspace, Databricks?
No, we're just seeing Zoom.
Zoom thing. Okay, sorry. Now,
Yeah. Okay. So your cluster is 212, right?
yeah,
That
it's the same cluster. If I go to configuration, see
yeah. 12,
12.2.
okay. Yeah.
Let me run it
Go
again.
to libraries.
Yep, I need to start it. And I had
You
that.
don't need to start that. You can go just click. Oh, okay. You started. Now you have to wait until it starts. You can go to libraries and install new Maven. Yeah, search packages.
Over here, I went to Event Central,
So, yes. Okay.
and it was dot. I had it copied. This is like few days back. Do you happen to know the? Let me go back to our.
Com.micro. So just check with Azure hyphen events hub hyphen Spark. Event hubs. Okay. Now,
Okay,
proceed
then it was this one, right?
the second, the
Second one.
second one. Yeah.
So that day it was throwing an error. Probably I was trying when it was still getting configured. I don't know. I was removing it and trying to install again. But let me see. I think this works. It's working. Looks like it's working now.
Okay. Yeah, just try that. See, I faced issues specifically here, because we're not able to search with the partial. There's some issue in the search. You have to give that
Mhm.
complete Azure hyphen event hubs hyphen Spark.
So I was copying this whole thing. So what I was doing is I was copying from here to here,
Oh,
and when
okay.
I was trying this, it was throwing an error.
Oh, okay. I think,
And then I tried putting the version two, the Scala version, and then the version, the whole thing. That was not working also.
yeah.
But now it's, yeah, so probably for next time I'll just put in this then.
Yeah.
So this,
I think, I mean, so once you create the cluster, it will be there. So you
yeah,
can
it should,
use
yeah.
that same cluster, start and stop and use the same cluster.
Yep, yep.
Okay. Um, okay. So, yeah. Naina, where are you with the configuration? I mean, did you try, or you had some issues, or how?
No, I don't. Actually, I didn't try it because
Okay.
I was busy this week.
Oh, okay. That's fine.
Yeah.
Fine. All right. So Hitesh's and Vamsi. Hey, Venkat. Naina. Okay.
Hi, Arun.
So I have shared more reference material there to try out apart from our video. I have also shared another YouTube video of the same use case, and I have also shared some previous week's video. So you can go through that as well for reference. It also talks about creating the accounts and setting up and configuration and all of that. Yeah.
And even the articles about CDC and SCD were good. That was a nice topic too.
Yeah, yeah, yeah. So towards the end of the course we want to try. So we want to try those as use cases or assignments for you guys to come up with a POC or something like that and do a demo for those topics. So that's why I've added that content there. And then we have use cases at the end of the document. So which we want to try it out at the end of the towards the second half of the course. Okay. Specifically for event hubs, I have actually added the reference in the same section 6 with event hubs. Okay. Let me share my screen and then we can get started. We'll reiterate some of the topics and then go from there. Okay. Okay. So we were talking about the streaming, right? So what did we talk about when we said stream is basically a micro batch? So you still read continuously, but with a shorter time interval of batches. So it may be 1 second or less than a second, whatever it is, milliseconds or so you give the trigger point when you want to go back and look for the data, poll and look for the data and bring in the data. So what happens when you actually, how is it implemented in streaming, right? So you are getting data, first file, then you are getting another data, second file. Now you have two files of data in the stream, right? In the Spark environment that you are pulling in. So how is the data treated? Basically, streaming is implemented in Spark as unbounded table, which means that internally within the Spark environment, it's all treated, structured streaming is treated as a table where each whenever at each interval, when you trigger and get the data, you just keep appending to the unbounded table. Okay, this is the first at T1. Say, for example, we're talking about T1, T2, T3, T4 times. T1 is when you start, right? At T1, you start and get some data from here. Okay, like event hubs, I first pinged one message. So that message comes in and sits here after 2 seconds because I put an interval of 2 seconds. So after 2 seconds, this will fire, right? And we read this data and then put it here. Then after 2 seconds like this. But here within the Spark environment, we have all these messages that have arrived with as a table appended to the unbounded table. Now, how long this data lives in the memory, right? So all the data is coming in, you have in memory, it cannot be forever. So basically, that's when you define how much data you can hold as a watermark. The data beyond that watermark is removed from the unbounded table. But as and when the data is coming in, so let's say this is how it is implemented. Got it? Any questions on this before we move forward? It just whatever streaming data is coming in, it keeps appending to this unbounded table, which is in the memory for the Spark. Now, this is where you have to see how much data is streaming, the volume, how much memory we have, and what is the watermark that we are defining, basically. And then are we doing an aggregates, or if we are just writing to the table, from there, we can just use the table and then remove this data. So first we are writing to bronze table. Let's say if we have million records that are coming in and we are writing 100K here. So the bronze table can have million records, but in the memory, let's say I have defined watermark. Say I want only the last 10 minutes. So last 10 minutes, there may be 100K records. So the previous 900K will be removed from the memory. So in the memory, you have 100K from the last watermark. But in the bronze table, since you have already written to the table, you have all the data there. Right? Everybody?
Harun, sorry. Why is it called as unbounded table?
Yeah, so there's no bounds or boundary here, right? As and when the data is coming in, you can keep adding as a appending to the table.
Okay.
There is no boundary here that it can only write to this table. It's like open. That's why it says unbounded.
Okay. There's no limit on.
Yeah, no limit on. It's just the memory that how much you can
Got
keep
it.
adding to the table. So it's not actually it's just a wrapper, just viewed as a table wrapper. It's just the data that is being stored in memory, right? So what is how do you visualize this result table is, see every trigger interval, what you say, so every 1 second, a new row gets appended to the input table, which eventually updates the result table, right? So which means, so we are reading every 1 second at T1, okay? T1 is, let's say in the event hubs at T1, I have published 10 messages. So all 10 messages come here. Now at T2, which means say after another, let's say my trigger is 5 minutes or whatever. So I go back and read after 5 minutes. And by that time, there are another 5 messages. So this at T2, I get, see the size of this. So 10 plus another 5, 15 records will be here. Okay. At T3, say after another 5 minutes, there are another 20 messages that I have published. So 20 plus 5 plus 10. So there will be 35 records here at T3. T3 is say after 15 minutes because I'm reading every 5 minutes. So there is some kind of correlation here that you have to be careful of what is a trigger and what is the event times that is produced. Now, in the event hub, I might be publishing data every 1 second or 2 seconds, but I might be only reading after 1 minute. So all the data that is accumulated for last 1 minute in the event hub is read, basically from what I have read previously. So that is what internally it stores, how much data it has read and what data it has to read next. Okay, so that intelligence is already there. So result T1, T2, T3 is basically if you want to add up, aggregate any data. So here you are aggregating this data, here you are aggregating this entire data. Okay, so let's say you are getting daily revenue from a store, and then you're not writing, you want to aggregate it within the memory every 1 hour. Now, first hour, you aggregate the sales of first 1 hour. Second hour, you aggregate the data of the first 2 hours. Next, you aggregate the data of 3 hours. As long as the data, the watermark, you want to retain, say, 10 hours of data. So until 10 hours, you can still use that. So this is how you correlate based on the trigger time. Now, when the data is coming in, most of the times the data will have its own timestamp. That is when the data has actually arrived, not when we have read. Okay. So let's say the store started selling at 9 a.m. Okay. And I am reading at 10 a.m. the data. So all from 9 a.m. to 10 a.m. all the data is published. But what transaction happened at 9:10, 9:15, 9:20, 9:30? So each individual transaction, let's say there are like 10,000 records that have come in. So each record will have its own timestamp. That is the event time. The event when it was generated. And then the event is T1 is when we have read that event. Are you guys clear? When the data is generated, say in the event hub, and when we are reading it in the Databricks stream, two different times. Got it? Any questions, Raju? Hitesh?
So far, no, sir. Thank you.
So Harun, what is exactly the result here? Is that what we have read?
Yeah, so data is already up to here. This is the result that we want to aggregate or read completely at T3. So we will go forward and see actually how the data looks like at each time interval. See here. But other than that, the concept is you got it, right? See the
Yeah.
time and the time we are reading, time window, because we are going into windows here. Because streaming, you have to make sure at each point how much of data you are considering to read or process, basically. So you'll split into those windows. Now let's say here input unbounded table of all input here. So this is the unbounded table where we said the data keeps adding to this. Okay. At T1, Netcat, I said, Netcat is some utility where you can just from your laptop, you can just publish some data to a port Unix utility. Cat, dog, dog, dog. So this is all data that I have published at T1 and we have read this data. Now, when I aggregate this, say, let's say I want to do word count. Cat is 1, dog is 3 at T1. We are all clear at this? Everybody?
Yes, sir.
Yes, Harun.
Okay. Now at T2, after this, there's two more words that were published, owl and cat. So owl and cat are appended to this unbounded table. So now initially we had 2 rows. Now we got another row, owl and cat. So now we have total 3 rows here. When I do the word count, cat is now 2. So here cat was only 1 when I did the aggregation. But since now I'm considering the data, all of this data, now cat is 2. So which means our aggregation is actually updated at T2 because now I'm considering all the data from T1 up to T2. So cat is 2, dog is still 3, but owl there is one more. So owl is 1. This is the aggregation when I do say count at T2. This is what I get. Now after another 5 minutes or whatever interval, T3. Now again, in this time, I got another dog and owl. So you get one dog, one owl appended to this. And then when you do the aggregate, you get cat 2, dog is 4, owl is 2. So at T3, this is the aggregated data you get. Exactly like we were talking if you want to do a sales revenue at T1, T2, T3. So how you get based on each store or each product, you aggregate like this. Say for example, the same thing. If I'm getting this, I'm not doing aggregation. I'm just writing this to delta table, right? So you will write cat dog, you will write dog dog again into the delta table. And when T2 comes, you should not write the entire thing. You should only write the delta, owl and cat, the new data. So that's why all of this will be in the, as and when the new data is coming in, only that data you would write to the delta. That is why you have again your checkpoint. What are you actually writing to the data, to the table, and what is the new data that is coming in? And then you always append to the table. So finally, your delta table should also look same as this T3, where if you are writing to the delta. But if you are processing and aggregating within the streaming job, So this is how it looks like at each interval. Now you can also do joins within the streams. So you can take stream 1, join with a static table. You can do a stream 1 and stream 2 and join both. Okay. So that is how you do the basically how it is calculated in the processing. Now just take the same example here. Okay. Same input stream at different times. Okay. At each 5 minutes, we are calculating the input that is coming in. We saw that, right? But here you see you have a each window, you have a timestamp where it actually falls. So 12:02 it came, 12:03 it came, so it fall in this window, 12 to 12:05. These two came at 12:07, it falls in this window, and these two rows came here, it falls in this window. So this is called each window. Now you can do a window can be sliding window or overlapping window kind of a thing. But if you see here, windowed group aggregation with 10-minute windows, sliding every 5 minutes. Okay. So it's a 10 minutes window, sliding every 5 minutes. What does that mean? You're counting, incrementing, aggregating for each 10 minutes. But the data you are taking every 10 minutes is you're sliding every 5 minutes, which means at 12:10, if you take at this time 12:10, so this is the best time. At 12:10, if I want to take a 10-minute window, can you give me from what time to what time my data will be?
12:10 to 12:20.
12:20 is still not there. The data has not come in yet. I'm not going into future. I only can read the data that has already arrived in the past.
Okay, then it's from 12 to 12:10.
Exactly. So 10 minutes, the last 10 minutes of data I will take and aggregate at 12:10 because my window is 10 minutes. Then the sliding is every 5 minutes. So when will I do the next aggregate? After 5 minutes. So 12:15. So the window will slide here at 12:15. Now at 12:15, what is the data that I will do aggregation for last 10 minutes?
5 to 15.
12:05 to 12.
Right. So 12:05 to 12:15. This is the 10 minutes window, right? So what is happening here? The data from 12:05 to 12:10 is included in both the windows. See here from 12:05 to 12:10, right? Counts incremented 12:05 to 12:15, 12:10 to 12:20. So that is in the future. So 12:05 to 12:10 is included in this window and in this window. There is an overlap because we are only sliding 5 minutes, but the entire data you are taking is for last 10 minutes. Understood? This is a little, looks like a little complicated, but just understand that data is coming in at different intervals, and then we are aggregating the data for a set window, a interval. So last 5 minutes, last 10 minutes, last 15 minutes of data. And that I'm calculating every 5 minutes or 10. So it's just like give me hourly sales at each, and refresh every 15 minutes. So every 15 minutes, I want to see what is the sales for last 1 hour. So at 10 o'clock, I want to see what is the sales for last 1 hour. So last 1 hour at 10 o'clock is from 9 to 10. So that I will take and aggregate and show. Now at 10:15, I want to refresh the data again, the dashboard. So 10:15, still I want to get last 1 hour data. So from 10:15, the last 1 hour data goes to 9:15 to 10:15 window. Now again at 10:30, I want to refresh. So last 1 hour data is from 9:30 to 10:30. That's how the window is sliding. The sliding is basically when you want to refresh or calculate the new data. The window is how much data you want to calculate. That's it. Those two things. Okay. Don't need to stress too much about it. Just understand what is a window, what is sliding. Again, there are like multiple things, late arriving data and all of that. I don't want to go into it right now. But you just have to understand this is the window 10 minutes and this is the sliding that I want to refresh every 5 minutes. That is how you can use window in the when you're doing the group by. So watermark is 10 minutes. I want last 10 minutes data, group by, and then put the count. This is how you treat example. So don't worry about all of these things. Again, there are 3 different types of windows. What we discussed is the sliding window right now. If you want, you can read up what is a tumbling and what is a session. It gets more. I don't want to confuse you more at this point of time until you are more comfortable with the streaming data concept. So coming back to the basics, how the data is stored at each time interval and how it is aggregated and processed in the Databricks. Cool with this?
Yes, Harun.
Okay.
Yes.
All right. So let's get back to our event hubs. So I have this one we talked about. So the same thing. Today I want to again walk through because last week some of the some people felt it's a little complicated, but we'll review it again. So this is very important. Based on this, again, tomorrow you have to, going forward, there are some topics like Delta Live tables is basically the streaming thing that you automate the pipeline. So here, you understood what is an event hub, right? Anybody who can talk about what is event hubs in just 1 line, 2 line?
It's a streaming platform which publishes the data to the another to the target or the destination.
Okay. Vamshi?
Event Hub, right? It's an offering from Microsoft Azure.
Mhm.
Allows you to publish or consume. Same answer, right? Allows
Yeah.
you to publish and consume the data, and not just Databricks. It can be anything. You can write a small program in Python. It'll also do the same thing. Otherwise, JavaScript or Java, all that. One thing. Yeah, again, if you guys know Kafka, I think it's again based on Kafka. I think I don't know if Events Hub is based on Kafka or it is a totally brand new implementation by Microsoft.
It is a different product, but it has native built-in or native connectors to the Kafka to work with Kafka.
Oh, so it's not built on top of Kafka then. Okay. That's amazing.
Yeah. So if you look at this, yes. Event.
So another question would be: is this Event Hub? Like we just discussed, right? It's a streaming platform,
Right.
but is it also a persistent store?
Yes.
Is it allowed to be used as a store?
Um,
And what's the
it's more of
default
the,
retail?
yeah, it's more of the implementation, right? So you can, you still, it's just same as Kafka. You still persist, but you
Yeah.
define how long you want to keep the data there.
Correct.
The same,
And after that, it will
like,
be
yeah, so that will
purged.
be purged. Yes.
Right. Initially, Kafka started as okay, we are 100% purely, streaming platform. And then later they said, oh, you can also rely on Kafka as a persistent data store. And they were like, pushing it for a very hardly, Otherwise, without persistent storage, you are forced to consume it and then store it, like in these Delta tables and all that. Otherwise, some database, because otherwise, after
Yeah.
like 7 days, the events are gone. You cannot.
Yes,
It's
it is,
vaporized.
right? But the point is how long you want to stretch into the
Correct.
other area, right? If
Mm.
it wants to become a persistent storage, then what's the point of having it as hub and spoke model? I can as well write it to a database table and forget about it.
Correct.
Why do I need? See,
No,
I have a Databricks
right.
data table,
Yes.
and
I
as and when the
guess
data is
here's the
coming,
use case. I mean,
right?
here's the use case. So let's say you take a company like Chase Bank, and then it's publishing its data to a certain event hub. Let's say how many times the deposits were made in a particular month. Okay, and so you have deposits made in January like 100 or things like that, right? So you have system, like say you have one marketing system that's listening to that, and you have another system, analytical system, listening to that. So these two systems are fine, right? Because now they're consuming data and all that. Tomorrow you have a credit card system. Now it wants the data, but it wants the data from last 3 years. So if it is storing the data since last 5 years, for example, then yeah, it can pick up. But let's say it's only storing the data since last let's say 6 months. Then all of a sudden, this credit card system can only get the data for the last 6 months, streaming data for the last 6 months, not for the last 2 years, which is it's interested. So there are use cases where people will say, oh, even though it's a streaming platform, we do want it to be a persistent store. But that's not too much of an ask, but there are some use cases. Yeah. But again, like you mentioned, it's a sweet spot. It's
Yeah.
primarily targeted to be a streaming system. Then why do you want to overload it and call it also a persistent data store?
Yeah. So
Right.
basically, Kafka is not it's not actually a streaming system. It's like it's one of those where it falls into the messaging system, like pub/sub messaging systems, like you had earlier, TIBCO or NQ, or these kind of pub/sub hub-spoke model pub/sub systems, right? Where you publish and where you subscribe. All of that was the shortcoming of all of that was basically one of them was persistence, and the other was the watermarking. Read once or go back and read again, or set your own watermark based on the consumer, and instead of push to the consumers, it implemented a pull. So you just said I received messages, and so there are few problems, the industry problems that it solved, and then it kind of be there for the HubSpot system, and the persistence 7 days or whatever was, let's say consumer fails, right? And then they fix it, and then they want to go back and read. They lost some data. They want to go back and read from the last watermark. So to allow that, it's like 3 days or 7 days, ideally, is what the data we need to be here, so that any consumer, some consumer fails, they can come back in a day or 2 days and come back, and it is fixed. They read the data back from where the watermark was when it failed. So that was the whole idea. Now 3 days then became 7 days. We want more storage. Then again, it became replica, right? Kafka has like replication factor. So now you're storing 7 days of data, you are storing 3 replicas of the same data, and then you're being like paranoid storage. So it itself has become a big data store. If you keep streaming all of the data, replicate, it's like same HDFS. You are having a clone, 3 copies. You are storing last 7 days or 1 year, 3 years of data, and all the data that is streaming in, you're storing it here. And then all your consumers who are reading it, again, they are storing in their raw layer. Let's say if Databricks, it's a raw layer, or any other consumer that is reading. By default, they would not read, process, and forget. They would have some kind of persistence whenever they read, okay, I read this data and then dump here, and then I proceed to process that data. So now every consumer is storing the copy of the same data again, right? So ultimately, how many copies are we storing of the same data?
Right.
And
Multiple.
how long
Yeah.
are we storing it for?
Right. Yeah.
So
Even storage is expensive too.
yeah, I mean,
Very
it
expensive.
kind of became, they wanted to push it, saying that it became a myth that now processing is costlier, storage is cheaper. When the HDFS came, right, the big data came where you can store it on the cheaper machines and then have a fallback or failback, and then break the files into pieces and store it in wherever the space is, and then in that ways you can scale horizontally, add as many machines, but low cost machines. You don't need high cost blade servers for the storage. That's how it started. But later, when the hyperscalers and the cloud came in, even the storage became almost again, hiked up. So the point is that earlier also, like, you are having every department or every department within the organization was in silos. They are storing their own data, they are building their own applications, islands of data on that, and operating independently. We set out to solve that problem by moving everything onto the cloud and having one copy of the master data or one copy. And then we said data is cheap, dump everything, don't lose any data is mine, and all of that. And then we started again piling up all the data there, multiple copies of the same data, right? And then each team is taking that data and storing it again. So again, we came back to the same problem of having multiple copies of the data first, and then too much of data, because now we don't want to lose the data or purge the data and want to keep it forever, with the myth that data storage is cheaper. And then we want to mine all of the data, whatever we have. So long story short, right? We want to store it in S3. We want to store it in Kafka or Event Hubs. We want to store it in Databricks as and when it's coming in. Then once we give this data to the downstream systems, they want to store it, right? So basically, that's again becoming a kind of the same problem of repeating or processing and keeping the same data at multiple places. So what I would personally think is that, yes, you can keep it, but I think 7 days or a week or 30 days is what ideally, just to handle the failure of the consumers and then go back and read the historical data for last 7 days or 30 days. Because again, you read it, put it in Databricks. Databricks has again the time travel, historical data you can go back and get, and all of that.
Yeah,
Right?
thank you. Yeah.
Okay. Okay. All right. So yeah, so that is what it is. Like we discussed in the messaging systems earlier, which evolved into kind of now storage slash messaging slash streaming tools or applications. Kafka, same as the event hubs, where data that is being published can come into one central repository from multiple sources, right? So that's what as we are saying, financial data, okay, from all multiple sources, whatever financial the stock market data that is being published can come into one system, right? Or weather data, weather data coming in from all different IoT devices, sensors, can be published and come into one repository. Now, within the weather, you can say the normal, the temperature, the rain and wind and all of that can come. Each one can have its own place within that hub where they stream the data. As each partition or each topic, temperature can be one topic where temperatures around the world get published from different stations at different time. Morning 9 o'clock, this city, this is the temperature. 10 o'clock, this city, this is the temperature. Right? They keep publishing the data. Then there should be something like wind, direction and speed is one topic that gets published to that wind. Then there might be another topic for weather, rainfall. So this city at this time, this much rainfall is happened, kind of. So this is historical data as and when it is happening, you're publishing. There might be another topic for cyclones or tornadoes data that is published, right? Now, why all of these topics are published? Let's say on the other end, consumers, there's a weather prediction app which wants to predict the weather for tomorrow. It only predicts, let's say, what will be the temperature and rainfall. So it wants to read only that data. What was the temperature from different cities or in that region for last 30 days, or historically what data was coming in, what it was. So based on whatever algorithm and parameters, it wants to predict the temperature for that. Now, there might be some weather stations or applications who want to predict the tornadoes. So as and when they want to read only that data which is related to tornadoes, what's happening around the world in the tornadoes, if something is happening near the US, what will happen near Japan, kind of predictions that they want to do. So they might be interested in only that topic. So keeping it as a central repository where all data is coming in, and then consumers can choose what they want to read from that. Okay, it's kind of a library. All kind of books will be put in the library, and whoever is interested in that topic, they can read books related to that topic. It's that simple as that. And then, as we said, we will have some kind of segregation and storage. So watermarking, where we can go back and read the events from as and when it arrives, or we want to read from the beginning or based on the watermark that we do. So that's about the that's basically about the event hubs. I mean, it's same as the, again, even if you talk about Kafka also, I want you guys to try out Kafka also once you get comfortable with this, how to integrate Databricks with Kafka. I'll give you the use case on that and some guidance as well. But this is it for the event hubs. Any questions on this? I have some kind of, I think I've forwarded some material for event hubs as well to go through. Right? Okay. So we will get start into the another example about the weather data. Just give me 1 minute. I will be back. Keep talking about the event hubs. I'll be back in a minute. Okay. Now, last week, we have done Azure Event Hubs for Yellow Taxi data, right? So we come here and up into this. So data set, we used Yellow Taxi data set. There are other data sets. We said we can try this. Okay, so this is the weather data, and all of these are attributes that it will come with the weather data. Each of these is a column that we can see. The following properties from weather data set are going to be dynamic. So country, city, temperature, humidity, and wind speed will be dynamic. I think keep changing with the number of events that you send for sample. There is a clickstream data, which has timestamp, IP address, user ID, session, how the user is clicking on the web page or the browser application online web page. So that is the clickstream data that you get whenever the user clicks something, that event is generated and published. This is used to track the user experience on the website and also how the user is navigating, where he is interested, or how much time he's taking to navigate through the pages, which pages are not being used or utilized by the user, is not clicking on what some of the pages. So that this information is used to analyze all that user behavior, right? Then you have stocks data. Basically, this is a nested structure, symbol and price. We will talk about in the next class how to process the JSON files which has like nested structure inside it. Okay, flat structure, you can directly map one field to a column. But if he has like nested, then you have to write transformations to flatten this data, right? So that we will check that. Then you also have fraud collection data. So why I'm showing you this is I want you to try these data sets and write your own notebooks and submit it next week. Okay. Choose any of these data sets, maybe not stocks data, but all of the clickstream data, fraud collection data, and vehicle toll booth. Okay, this is also nested. Just take these ones. Basically, clickstream data, fraud call detection data. You can try this. Okay. Let's get into the weather data, this published thing here. So we are going to publish this data, and then I have this notebook to read the data from the weather events. Okay. So first, let's go and start the compute. This is the compute. I have confirm. Let it start. Okay. So we'll look at this again, same process. Weather data may be coming in from any IoT devices into the event hubs. So event hubs can generate, or so we are now simulating that coming like this, and then we are publishing into the Event Hub, generate and publish into the Event Hubs, just like the IoTs might be sending the weather data. So we generate that data and publish into Event Hub. From there, our Databricks streaming job will connect and read those events that are coming into Event Hubs and process all of these into bronze, silver, and gold aggregations. So that's the same process. We are using the same cluster. Last time we used 12.2, 212. Okay. This is the single node compute cluster. And don't use photon acceleration. It uses more DBUs or your credits. There is one checkbox when you create photon acceleration if you want it to speed up or have better performance. You can go and say that photon acceleration is not required. Basically, if you see here, uncheck this. If it is checked by default, uncheck this one. Okay. And terminate, make sure you put 20 minutes or 10 minutes, whatever. But anyways, it will not be charged if you're not using this.
So what is this photon acceleration? What's the
Photon
what is it for?
acceleration is the project from Databricks to improve the SQL engine. It has rewritten that in the C++, to be more native, and it gives you more performance when you run the jobs. So this is premium, so it costs more. So you can go. So Photon accelerates modern Apache Spark workloads, reducing your total cost per workload. It says that it will accelerate your Spark workloads. If you have a huge workload, it makes it faster, but it is kind of premium.
Okay. So while setting up these clusters, right, we don't have to worry about whether it's a GPU or a CPU, correct? You just tell the number of cores. Or
Yeah, it depends
should
on
we-
your it depends on your workload. If you
like in the industry, people say, okay, do they pay attention to whether it's a CPU or a GPU, or that's not still there?
some jobs where you have machine learning algorithms, huge crunching of data, so GPUs are more preferred. It's just the processing power. Okay?
Okay.
GPUs might take days or kind of a thing. It might take forever to process the same data when you have huge volumes. But for smaller volumes, CPUs are good enough. And then more.
Okay.
You just go.
So in the industry, depending on the kind of processing you do as a solutions architect and all that, you will say, okay, let me, of the 10 clusters I'm standing up, let me use 3 clusters for GPU and the rest 7 are CPU, something like that. Is that
Yes.
part of the responsibility?
For machine learning, AI prediction algorithms, you use GPUs where data crunching, there's heavy data crunching, and then you want faster results. For batch process, overnight there is some data coming in, you process and write it to the tables. You don't need GPUs, right? You have time, it's okay, even if it takes more time and it processes slow. So for those use cases, you use smaller machines with the CPUs. It's all a trade-off between the cost and the performance. All right, so Databricks Photon engine, it says, it's the next generation engine on Databricks platform that provides extremely faster query performance at low cost. No lock-in. It is actually written in the C++. Yeah, it's entirely written in C++, provides 2x speed. Basically, it has more faster engine when you enable that Photon engine. Okay.
Thank you. Thank you.
Okay, let's come back here. So basically uncheck this and terminate this, and then cluster is done. Now we go back here, shows weather data, notebook. So let's see if we have all of this is already there. Let me run this and run this. Okay. Okay. So all of these already exists. So we don't need to worry about this. So I have we have gold, bronze, gold, silver. Okay. And also see these are all created under the Hive Metastore. Just keep a note of it. The metadata of all these schema and tables is being stored in a Hive Metastore. Basically, what metadata and what is the database name, what is the table name, what is the column, what is the data type of the column, how many rows, all of this metadata is now is in the Hive Metastore here. We will in this next sessions, we will talk about what is Unity Catalog and how all of this has moved out from Hive Metastore to Hive Unity Catalog, because data governance and a lot of features are enabled on the Unity Catalog. That's the Databricks data governance platform. We'll talk about that, but for now, just remember we are using this in the all of this is now in the Hive Metastore, and that is based on what workspace and the workspace you have created. If it is UC enabled, which means if it is a Unity Catalog enabled, whatever catalog, you can create your own catalogs at this level. It will not be created under Hive Metastore. We'll talk about it in detail, but for now, just remember that whatever we are creating, it is in the Hive Metastore. The metadata is tracked in the Hive Metastore. Okay. We already have gold, silver, bronze schemas, and then we also have table weather. I created, I think, when I was testing. So what we will do, we will go and drop these tables. Let me go to SQL editor. Okay. And then I will just go here and say drop table bronze dot weather. So remember I told you, you also get a SQL editor where you can just talk to the Databricks Delta tables, just like any other SQL database client. You can run this. So it uses a warehouse, starter warehouse you can create for directly connecting to the Delta. It's not a cluster, the same cluster. It's a database, SQL warehouse that you use to connect to the database. Or you can just do the same thing from your notebook also. Write %SQL and then do this. It can actually use that same cluster to run this and drop the tables, right? You guys are able to correlate how we are doing from multiple things is the same thing end of the day.
I don't know.
Yes.
So when you created your tables and the schemas, it went directly to Hive Metastore, right? Under Hive Metastore.
Yes.
Is it something you specified, or because you didn't enable Unity Catalog, it did it that way?
Yeah, since the Unity Catalog is not enabled on this
Got it.
workspace, it directly goes to the
I
Hive.
see. Okay. And for me, it went to my workspace. That means I have Unity Catalog enabled.
Yeah. So by default, right now, all the whenever you create a workspace, it is automatically UC enabled.
Got it. Okay.
Okay. So this is another workspace I have created. If you go to here, catalog,
Hmm.
here
Got
there
it.
is Hive Metastore, but here there are like this is one catalog, UC workspace catalog that I created. So it goes here, not
Yep.
into under this. So whatever schema I created, demo schema is under UC workspace, and tables and volumes are in the schema. So this is when UC is enabled. I think you get somewhere it says whether it is UC enabled or not. If you look at the workspace when you create Databricks workspace, you can see that it is UC enabled or not.
Got it.
Okay, coming back here. Why is it taking so long? Just start the warehouse.
Arun?
Yeah.
Yeah, so I wanted to know how does using SQL editor to query the data tables compare when you're using a cluster instead?
It doesn't matter. That's what I'm saying, right?
Does not matter at all.
Does not
Okay.
matter at all. End of the day, see, it's like you are writing a SQL script and running it from the application, or you're connecting to the database using a client and running the SQL. It's the same thing. End of the day, they all go and do the same thing, drop the table in the database. Now, what resources does it use? If you run from your notebook, it uses the cluster to run those SQLs. If you run from here, it uses the starter warehouse to do that. Now, how you do that is basically, again, each team, some teams may not have, they'll not give access at the cluster level to have some kind of permissions. It can have only read-only permissions on the database. So in that case, you will not be able to drop or truncate tables or something like that. To enforce that, they create some separate warehouse to connect to the databases.
Okay.
Okay. I don't know why this is stuck. Cancel. Sometimes it takes forever to get this warehouse and all of that. Let me try and do, since my cluster is already up. Where's the cluster? This is the one. Yeah, this is the one. I will just go and write %SQL drop table bronze dot weather drop table silver dot weather drop table gold dot weather summary. Okay, let's just run this. Okay, that's done. Now we will execute. So there is no change in the connection endpoint that we see. We are using the same endpoint event hubs. We are using the same event hub name, Starbricks demo. If you want, you can create another event hub. That's totally fine. And this is the connection string. I will run this. This is done. Now again, data frame spark dot read stream event hubs. We are displaying data. So where is this clear output? Write stream. I'm giving some mount point, checkpoint location, output model append, format delta, table bronze.weather. I have dropped the table, it will automatically create. And then I can start this stream. It keeps polling and looking for the data. Correct? Any questions on this part? Guys, ask me now. Anybody? All of you have to submit assignment reading the data from the other data set. Lahari, Raju, Hitesh.
No, it's clear.
Okay. Who else we have? Naina, Varsha. Varsha is fine. Yeah, we can give her another week to catch up. Naina?
It's clear, Arun. I'm
Okay.
trying to understand.
Yeah. If you have any questions, let me know or ping me, but take some time out this week for to write your own streaming application from Event Hubs using one of those data sets that I will give, ask you to. Either fraud detection, I think, yeah, you can take that. Okay, so we are running this. There is no data yet. It's running, and as it runs, we go to, what is this? Yeah, catalog, bronze. We have the weather table created. Okay, there is no silver or gold, no tables, no weather data tables in this. Go back. We are reading the stream. Format is Event Hub because we are reading from Event Hubs. Options. This is how, in Python, you give a dynamic set of parameters. So ehconf, it may have any number of key value pairs. So this is the key, this is the value, this is the key, this is value, and it may have many more, right? So they just give ** ehconf. So each of this will be passed as a separate parameter, as an option. Each parameter will be passed as a separate option into the read stream. And then load, we are displaying the data. Truncate false, it just says that don't truncate when you are displaying, display the entire data. And then we are writing the data into this bronze.weather table. Format is delta. Output mode, when you are writing, you are appending to the table whatever data that is coming in. Checkpoint location is this checkpoint location, weather 1. Now, once this is coming, so we want to provide the schema. So what are all the columns or information that is available in the stream that is coming in, or the message that is coming in? Temperature, humidity, wind speed, wind direction, precipitation, and conditions. Okay. Go back here and see in the weather data. So all of these are there, but we are only parsing few of the fields from this weather data. So you can add more, you can parse more attributes. If you want to read all of the attributes, you can read all of the attributes as well. I believe, yeah. So you can add all of the attributes, but you can choose, say, I don't want to read, there's a lot of data that is coming in the message. I don't want to read and parse all of that. I just want whatever is needed for me. I don't need UV index. I don't need dew point, pressure, or whatever. So whatever attributes that I want, I will only read those from the message and parse it. So I choose 6 from here. And what are integers and what are string? You create this. Struct field is each field you give name of the column and data type. So these are all available when you do here. What are the types that are available when you want to define? These are part of the SQL types. You can go and read what are the types that are available: integer type, string type, float type, decimal type, Boolean type. So all of them, whatever is the standard database column data types available, are available in the PySpark SQL types. Functions, you will have some SQL functions here that you are using. So that is also available in the Spark SQL functions library. Take all of the fields, put it in a struct type. This is an array of all the fields, and each field has these two parameters: temperature, not name and data type. And then there is one more parameter, nullable, true, false, that also you can provide. That is optional. Now you take this schema to parse. Now next step is you are reading the stream from Delta table. So once you are reading this incoming stream, you have written that data to the, let me stop. We are not doing this here. We'll start it again later. So reading from the Delta table, bronze, where you have already written the data from the stream with column transformation. With column, you are adding a column called body. You are taking the incoming column body as casting it into a string. And then again, same column body from JSON, column of body JSON schema. So this is the function. So you have used, right, Spark SQL functions. What this function is doing is it is taking this column here, whatever you did body. Let me say body, JSON string. So this is the column, body is coming in, you cast it as a string, and then we are creating the column body JSON string. Next step, again, you take the same body JSON string, apply the JSON schema, these fields, columns, to parse that JSON string, and then read it in a column called body. Okay, so finally we have this column as body, and from that you select body dot all these fields: temperature, humidity, wind speed, wind direction, precipitation, conditions, and column of enqueue time as alias timestamp. So then you get all of these columns once you read from that data frame, once you transform. Everybody got this? Any questions on how we are doing these transformations step by step?
Yes, sir.
Okay. Go back again. Everything is in these 3 lines. Whatever is incoming as body, you're taking it and casting it, converting into a string. That string we are calling as body JSON string column. Then again, we are taking that column and applying our schema. What are all the columns in there and what are all the data types? And using this function to do the parsing from JSON string to our columns. And then we are calling that output as body. Now from the body, because it has all of these columns, you can go and read body dot temperature dot humidity dot wind speed in this dot notation to extract each column out of that, and then add another timestamp. That's how you get here output data. So you're writing again append to weather, silver weather. The next part here you see here is now your bronze is done, your silver is done, your transformation is done. Now we come to gold. Okay, we'll come to gold this. Let us first run till this part and see what's happening, right? Okay, you want to see how we process until here? Initializing just the string data, go here, I'll just publish one, send, and see if we are able to read the data here. Okay, so we are able to read the data. Now, if you observe, what are the columns that we are getting in the message? We are only getting this called body, right? Guys, are you with me?
Yes, sir.
And do you see any data that we have published from this? From here?
No.
No, right? So because it is all encrypted. You see here, it is a binary data type. See, the body data type is binary. And all the information is encrypted in this body. Partition is find one, offset sequence number. This is all metadata. What is the enqueued time? What is the time that this event was enqueued? Okay. Partition key, system properties. This is all metadata that comes with the message. And the actual message is encrypted in this column called body. So that is why we are taking this body here, this body, and first casting it to string from binary. That is when you get all the information as a string. Maybe if I just remove this. And this, we'll come back to this. We'll just add step by step and run this. Okay. See, this is, yeah.
So the encryption,
Hmm.
does it happen at the transportation layer, or are we specifying something while reading into bronze?
No, I think by default it happens at the event hub when you are reading it.
Okay.
It's
It's
encrypted
just
and transported. Yeah. Yeah, you need it encrypted while transport. Yes. Yeah. So here, see, body is still encrypted binary, but we have added a new column called body JSON str. This is string. See here, and now you can see all the data that is encrypted in that body. This is what you have in body JSON string. Even now you just got whatever you have published. It's just the JSON structure. Now you have to parse this. I know we should have done the JSON parsing before we did streaming, but we will do that. But as of now, now this body JSON string, this is a string. We have cast it in string. Now we are taking this body JSON string and applying our JSON schema here. The schema using a function from JSON, and then we are calling again body. So let me remove this body and say body parsed. Okay. And I will stop this. And in this. And run this again and see. Image not defined. Where are those? Okay. Okay, now you see body. This is a JSON string. We have parsed it to a string from binary. Now this is a parsed string. Okay, parsed string is object. Now you can see temperature is 24, humidity 62, wind speed 15. It looks similar, but not in the JSON format anymore. It is in this body parsed. It's an object. So how do you access attributes of an object? By dot notation, right? So if you have a class and its attribute, you say class dot attribute, just like you are doing schema dot table. Same thing, object dot field. So the next parsing is I am doing select from this body dot column name. So since we are not calling it body, we are calling it body parsed. So I have to use in dot notation everywhere body parsed dot that column name. Hey, what's up? Okay. Now when I run this, I get only these columns because I'm only selecting these. So you won't see now body JSON str or body parsed because I'm not selecting those columns in the transformation. I'm only selecting these columns. So now I have parsed and got just like a table, column and data. Binary, this is integer 24, 62, strings, timestamp, all of this. This is as per the schema that you have defined. Good. Now we got how the entire message that is published from Event Hub is now parsed into the data that we need. So if I want another field, another attribute that I want to read from this, let's say I want to also have country. Country is there already? No, country is not there. Okay. So let's say I want to add a country to this. Now, how do we do that? Where all do I need to change? I will just interrupt this. Oh, everything is gone. Okay. Now tell me where all do I need to change, add that attribute. So this is most common use case, even in the industry, and there is some job running, the source of business, wants additional information. Okay. Maybe some tax information I want additionally, or there is a new regulation to report for each country. Now we want to report the discounts or the tax percentage or the emissions that happens for the product, whatever it is, regulatory, that now we want to report. So to calculate that, we need more information from the source. Okay. So maybe to calculate the tax, we need there's a new GST tax in India. So to calculate that, what do we need? Maybe we need what is the percentage on the product category. Now we are getting the product. We don't know what is the category it belongs to. So now we want to go back and ask the source, hey, I need to calculate the GST, but to calculate GST, it is at the category level, not at the product level. So I want to know what is the category. Does it come under electronics? Does it come under basics, or does it come under luxury goods? Right. So I want that. So the source says, okay, I'm adding that in the message and sending it to you, the category. Now you have to take that and process, right? Anush and Vamshi, is that a common use case?
Yeah, it is.
Yeah.
It is.
Okay. So now let's say example of that. Now they are providing. Now I want to add new attribute. So where do I add?
You can go down.
Yeah. Let me ask Raju. Where all I do need to add first? The code, new
I
attribute.
think you can add at the JSON schema level and then define it at the with column in the next one.
Okay. So I will go and add. So I'm going to have a new field called
There.
and then I leave it as a string type.
Right.
So now my new JSON schema has country as well. The parsing is done. This parsing is done based on JSON schema. So now I will have body parsed dot here country, right?
So, but like if you go 2 lines above,
Mhm.
because the country is still empty, right? You only defined, you did not populate it. So can you, after that, with column is there, right? In that with column, can you put country there and then do the parsing and populate it?
I don't need to.
Because it's a derived column, right? It's not coming from the CSV directly, right? It's a derived column.
It is. That's why I took this country.
Oh, it's there already. Oh, sorry.
Yeah.
I thought you're
Already.
deriving. So let's take an example. Let's say if we say, like in this case, right, country is coming from there, right? But let's say it's a derived column. Let's say let's put another column called city country, right? Which is basically a concatenation of a city and country, right? Now it's a formulation column.
Mhm.
In those cases,
Yeah,
can we take this?
Yeah, it's the same transformation you are doing here, right? Column, include column like this. So you can say with column, okay? You
Right,
can
with
add
column.
body parsed dot city plus body parsed dot country. That's
country. Question is, should you on the top, should you define a struct field, which is basically a placeholder, and later we formulate it in the
Yes,
next.
if you want country plus city,
right?
If it is in the source and you are parsing it, you should define here.
Correct.
If you don't need, let me complete. So if you don't need, if it is not there in the source, if it is purely you are adding new field like this, then you don't need to define it here. See, I have not defined enqueue time here. Okay. So I'm just creating a new column enqueue time.
I see. Okay.
And doing it as
so you're okay. That's my question. So you're saying that you don't have to define at the top on that level. It would be nice if there is some that column, that 14, right? The 14 is there, right? 14 cell 14.
This one enqueue time is in the source. Okay. But it's already in the timestamp. I don't need to parse it. I don't need to add it or anything. So I can directly use this field as is enqueue time and then rename it as timestamp.
Right. You're renaming there. But of course, even when you're renaming, you're actually like kind of adding in that.
Right. Yeah. So if you want to say add a new column with this, now again, you can go here and say with column.
Okay.
Right. And then you say whatever city country.
Yeah.
And then you can say column of what is So you have already, let's say, parsed it to country right here.
Yeah.
You can say country, column of country, and a plus column of, if you have city parsed already, you can put city. But since I have not added city here yet, it will fail.
Mhm.
So I have to add city also in this, and then parse it here using body parse dot city. Then I get both country and city. Then I can say create a new column called city country, and then use those existing two columns to just concatenate and make a new column called city country.
Correct. Okay. Yeah, I thought even those are formulation columns. I thought you had to define in that cell 14.
No, this is only for parsing the existing source. For
Existing. It's
transformation,
already
you
there.
can do whatever you want. You are adding new ones.
Right. So another question is, so the names have to match exactly, right? So if you do a spelling mistake,
Yeah,
country,
it will,
if you do a
it will error
typo,
out. It will try to
yeah,
find that column in the JSON. It does not find, it will throw
it'll
error.
error out, right? If you say CONTRY instead of COUNTRY, it's a typo.
Yeah.
Then it will fail then. Okay.
Yes. Yeah, sometimes it will fail. Sometimes it silently thinks that you are looking for another field called country and it is not there. It will just give you null values. So there is a
Okay.
mismatch, right?
Okay.
So
So it gives
country
a
is
null
actually
value.
coming in, but it
Right.
feels we are looking for some other attribute called CONTRY, which is not there in the source. So it will default it to null. Now,
Okay.
if null is acceptable or not, you say here Boolean, right? So if you say nullable false, then it will throw error. There is no value, there is no this field available. But by default, if it's true, it will silently just keep populating null. So you can try that out and
How do you specify whether it's null or not right there?
you can just say true false.
No, false. Okay. Right there.
Yeah, just like that. I think in codes or the syntax that you can check, but
Okay.
it's just like
Got
true or false here. Okay. Anything else? Okay. All right. So now we have defined country. We have run this. Now I'm parsing the country also. And I will start the stream. And here, oh, okay, this is gold. We don't need to go there. Just display. So I will now should get body parsed country. See here, USA. Okay, now I got the new attribute as well. So you can go ahead and write this to the silver. Stop this and publish this. So it will write to the silver thread. Now here is what we talked about the windows, right? With watermark. I want last 5 minutes, group by window, timestamp 5 minutes. So I'm taking a window of last 5 minutes, okay? And calculating the average of temperature, average humidity, average wind speed, average precipitation, right? And selecting window.start, window.end times. So what is the start time of the window or what is the end time of the window? And these values, whatever we have calculated. Okay. Let me run this again and see how we are calculating this. So where is this? We did, it's running. Okay. Right stream. Right stream. Illegal state. Okay. When this may happen when you change the code to read from a new table or you deleted and recreated a table. So since we did some changes, so we have to change your checkpoint because the information that it has saved is different from what you're trying to look now, right? So that's why it's throwing that error. So we can go stop this. This we are still reading and then say give a new checkpoint and then run, or probably we have to merge the schema because we are getting a new field now. Okay, now we have in the country here. Now I will go and do the aggregation here. Let me plug in my charging. Okay, so if you see here, this is the start time and end time, 1625 to 1630, based on the event times that it has. So I took a 5-minute window and calculated this averages. Basically, it has only one record, so average will also the same 24, 62, 15, 0. You will have same 24, 62, 15, 0 since there are no other events in that window. There's only one record, right? So the timestamp 11/9/1628. So 11/09/1628. It's a 5-minute window. 1625 to 1630. It has taken that 5-minute window to calculate. Got it? Now go back, add more events and see if our aggregations change. So I'm sending 10 this 10 events from the source, and we want to see how our aggregations change based on the event times and aggregation. So now the entire streaming pipeline is running from source to target to the right to the aggregations. Okay, now we got another window because there is a new event 1650 to 1655. There is another window. These are the average values. See, now there are more events. See, the average values have changed within that same window, 1650 to 1655. Now it's changed again. See, so it's calculating the 5-minute windows every time it is refreshing. Every time the new data is coming in, it's consolidating, considering all the data in that window, and then recalculating the averages. This is what we talked about at T1, T2, T3. Whatever data that is available, it will take within that window and recalculate the values. Right? 1650 to 1655. If you go here and see all these records, these are timestamp is 1651. So all this data that is coming in at 1651 fall under that window, 1650 to 1655. So that is why it is aggregating all of this data. Okay. However, the first row has not changed because there are no events that have come in that time. Everybody clear? How the streaming is working, how we are aggregating windows, how does the aggregation work? Any questions? Come on, team. Yes, no.
Yes.
Lahari, Hitesh, Anush, Vamshi,
No.
Naina. All good?
Yes, sir.
Okay. So I think this is enough for us today to wrap up. I will publish the recording, and here is your assignment. So go to this fraud call detection and write a notebook to same thing to process this information. Okay. Fraud call and clickstream data. You can use any of these two data sets and write your notebook, streaming notebook. This is actually, you have to, car model is a nested structure. Basically, it's one level down. Instead of body dot state, you do, right? So you will actually do body dot car model dot make, body dot car model dot model, right? So two level that you just need to.
So while defining the structure for that level, do we have to create? So currently, since it's a string, we are directly declaring it as that, right? So when we're creating the structure, also we have to change it, right? Because it's going to be.
No, your schema will still only these columns. You will not do a car model. You will just create fields for entry time, make, model, vehicle type, vehicle weight. What changes is basically, see here you will just do car model, make, only that part. Here also you would do the same thing. Here also you would do the same thing. Only in the parsing here you will say car model, so body parsed dot car model dot make.
So it directly parses it without us declaring what type it is. Okay.
Yes. All you need to do is the lowest level attributes that you want. Okay. You can try that if you want to, but yeah, as of now, so you can try. If you just want to try flatten, this is the best one: fraud call detection or the clickstream data. If you want to just try it out and see how it works, go ahead and do vehicle toll booth. It's just car model make. Or even if you don't want, you can just ignore this entire thing and just parse these things. It's up to you. But any of these three, it's better if you try this also. Take these data sets and create your own streaming application notebook and submit the next week. Tomorrow, I may not be able to take the session because tomorrow we have a GenAI event for iGebra. We are having a representation in one of the events tomorrow. We are demoing our GenAI for kids. in the RL Turnal High School. So I will be there whole day event for that. So I may not be able to attend the session tomorrow. I will check with Srini if he is available to session, or maybe we will schedule it to some other time. Okay.
Thank you, Harun.
Okay, Harun.
Sure.
you.
Any other questions?